Programming is not like math. You never use postulates or axioms or any of those things while you're programming. Well, unless you're using a proof assistant like Lean, Coq, or Agda. Proof assistants are just programming languages, and they definitely allow you to talk about axioms and postulates. So what gives? Can we bring this logic down and also talk about axioms in a more conventional language like TypeScript? Sure we can. Look, it says that every array is non-empty, and it provides proof of that by promising to extract an element from an array of A's. Now this axiom is false, so obviously we can't provide a proof of it. Here's how we derive a contradiction, or an element of the never type. We take an array of nevers and then produce a never from it. The empty array is an array of nevers, so we're good. Now notice when we first defined our axiom, we filled its formal definition, not the type level definition, but the actual value definition with some nonsense garbage. This is basically how every proof assistant handles axioms, although usually they'll have some syntactic sugar around it. If you were to try to evaluate this axiom, you would get a runtime error, or in some form of halted computation where it can't proceed because it makes no more sense. Now we're going to note that in any type theory, it doesn't make sense to say that an axiom is true unless it is also a theorem and you can prove it. A proof would imply that you replace the empty garbage inside the axiom with something that actually type checks. Now an axiom could be uncontroversially true and therefore a theorem, or it could be false, like this one, or it could be the third interesting case, which is something that is not false but also not provable. The classic example here is double negation elimination, or the law of excluded middle. You cannot disprove the statement, but you also cannot prove it. It exists somewhere in between. It's not going to cause any problems if you add it to your language, unless you ever try to run it, in which case it'll crash the same as any other axiom.